Math 3, complex numbers. Again, we're still in the review unit. So sometimes we will encounter equations that have no real solutions, and we have to rely on a number system with the complex unit indicated by the letter I. Some people refer to these as imaginary numbers, and I don't like that reference because they aren't imaginary. They exist in real life. They just are less frequent, I guess is the word for it. And you need to know them, and I will always call them complex because the word imaginary tends to freak out customers. So don't let that freak you out. It's just complex. We can take the square root of positive numbers, like the square root of 9 is 3, because 3 squared equals 9. And technically, the correct answer is plus and minus 3, because positive 3, so 3 times 3 equals, oh, and that's a typo, equals 9. Or negative 3 times negative 3 also gives you positive 9. But we can't take the square root of a negative number like that because no number multiplied by itself will give you a negative, because positive times positive is positive, negative times negative is positive. So we will use I and I squared. I is the square root of negative 1, and I squared is negative 1. So for these examples, we have the square root of negative 121. Well, the square root of 121 is 11, right? This is equivalent to the square root of negative 1 times the square root of 121. The square root of negative 1 we know is I. The square root of 121 is 11. Whenever you take the square root of something when you're solving, it'll be positive and negative. So this is just going to be 11i. But when you're solving, you always put that positive and negative out front. The next one, the square root of negative 28. This is equivalent to the square root of negative 1 times the square root of 28. 28 is not a perfect square, so we need to list its factors. 1 and 28, 2 and 14, 4 and 7. 4 and 7 are going to be the factors we use. This is equivalent to the square root of negative 1 times the square root of 4 times the square root of 7. Square root of negative 1 is I, the square root of 4 is 2, so we have 2i, and then root 7 is left over. Now when we operate with these complex numbers, you just operate on them as if I were a variable. So 5 times 2i is just 10i. The next one, negative 3i times 2i. Negative 3 times 2 is negative 6. I times I is I squared. Never leave it as I squared. Always take that and plug it back in with a negative 1. So this is equivalent to negative 6 times negative 1, which is positive 6. Adding and subtracting, you're going to do the same thing we just did. Again, to treat it as a variable, you can only combine the real and the complex pieces with one another. So negative 2 plus 1 is negative 1. And 5i minus 7i is negative 2i. And that's it on that one. The only difference between addition and subtraction is you need to distribute that negative. You have 4 plus 6i plus 1 minus 2i. Just make sure it goes into both places. That's where most of the mistakes are made here. 4 plus 1 is 5. 6i minus 2i is 4i. Multiplying, you have to FOIL it out. So FOIL, first, outer, inner, last. Hopefully you remember that. So we take the 2 into both pieces here and the 4i into both pieces. 2 times 9 is 18. 2 times negative 3 is negative 6i. 4i times 9 is 36i. And 4i times negative 3i is negative 12i squared. Combine your like terms. 18 plus 30i, and know that I squared is negative 1. You get 18 plus 30i plus 12, and then combine your last terms there. And 18 plus 12 is 30, so you get 30 plus 30i. One more. Again, FOILing. 1 times 3 is 3. 1 times negative 6i is negative 6i. 4i times 3 is 12i. 4i times negative 6i is negative 24i squared. Combine your like terms and know that I squared is negative 1. We have 3 plus 6i minus 24 times negative 1. 3 plus 6i plus 24. Combine your like terms. You get 27 plus 6i. Complex conjugates. So when you're dividing complex numbers, your answer cannot have I in the denominator. Just like with fractions, you can't have a radical in the denominator. You can't have I in the denominator either. So every complex number has a complex conjugate, and it's essentially a negated complex term. A negated complex term. So here, in order to get that out of the denominator, you're going to multiply top and bottom by the conjugate. That's a J. By the conjugate. So this one, we have an I. So the conjugate is negative I. So if the conjugate is negative I, I'm multiplying both the top and the bottom by negative I. When there's more than one thing, you have to distribute it to both pieces. So 2 times negative I is negative 2I. 3I times negative I is negative 3I squared. That's the top. And on the bottom, I times negative I is negative I squared. Simplifying that, I have negative 2I minus 3 times negative 1 over negative 1, which is 3 minus 2I on top over 1, which is just 3 minus 2I. The next one, I have 1 plus 2I. That conjugate is 1 minus 2I. You just negate or change the sign of your complex term. So I'm multiplying both the top and the bottom by 1 minus 2I. Now with this one, I will have to FOIL out the denominator, but the top one I can just distribute. So I'm left with 8 minus 16I on top. And then I'm FOILing these out. So 1 times 1 is 1. 1 times negative 2I is negative 2I. 2I times 1 is positive 2I. And 2I times negative 2I is negative 4I squared. Combine my like terms, negative 2I and positive 2I cancel out. That's why you have to use the conjugate, because if you don't, then those I terms are going to cancel out when you have to FOIL. And you have 8 minus 16I on top. Remember that the I squared is negative 1. 8 minus 16I over 1. Negative 4 times negative 1 is positive 4, so 1 plus 4 is 5. The last one there, 2 plus I over 1 minus I. If my complex piece is 1 minus I, then its conjugate is 1 plus I. So I'm multiplying both the top and the bottom by 1 plus I. Again, I'm FOILing here, so I'm putting it all in parentheses. 2 times 1 is 2. 2 times I is 2I. I times 1 is I. I times I is I squared. 1 times 1 is 1. 1 times I is I. Negative I times 1 is negative I. Negative I times I is negative I squared. Combining my like terms, on the top, I have 2I plus I, which is 3I, and then my I squared is negative 1. On the bottom, my positive and negative I cancel out. My I squared is negative 1. 2 minus 1 is 1 plus 3I on top. And then 1 minus negative 1 is 2. this to start solving quadratic equations and just with the square roots. So solving with square roots here, I'm going to get my x squared term by itself and then take the square root. When I take the square root, I have to put a positive and negative in front of it. And if there's a negative under my radical, I have to take an I out. I'm going to start with subtracting 20 from both sides of this equation. 5x squared equals negative 20. Divide both sides by 5. X squared equals negative 4. Take the square root. When you take the square root, you have to have the positive and negative square root. The square root of 4 is 2. Because there's a negative under there, we have to have the I with it. So 2i. And then the last one, subtract 5 from both sides. You get 3x squared equals negative 72. Divide both sides by 3. You get x squared equals negative 24. Take the square root. And you get x squared equals, I need factors of 24 that are perfect square factors. So that is going to be 6 and 4. You don't get x squared equals. You get x equals plus and minus the square root of 4, the square root of 6, and the square root of negative 1. The square root of 4 is 2. The square root of negative 1 is I. And then 6 is not simplifiable, so it stays under the radical.